Hello, class. I'm going to do a recording for section 4.4, Counting Rules for Statistics. And this is located in your workbook, page 118. Okay. Let's see. So the first thing is I want you to notice towards the back of this section 4.4, we have some important, an important summary of the counting rules. And so, on your quizzes and tests, I generally want you to provide the formula or the symbol and then the substitutions and then, and then your answer, right? You identify your answer, but you support your answer with your work. So these are the kind of, formulas and things that I'll want. This is the formula needed for the fundamental counting rule. Um, there is a permutation rule that we're going to go over. And actually, this would be fine, the formula for that, or the abbreviation. Uh, your Connect Math videos, right now in the enhanced version of the Connect Math, um, they make use of, in some of the videos, they don't show you from the I think they hardly show you from the TI-84. Some of those Connect Math videos that we have available at this time during the recording, the Zoom recording, they sometimes they show you how to do things old school by hand, which some of our dual credit students, like we have dual credit students who take statistics at Wagner High School, for example, or at Brackenridge High School, for example. So some of those stats instructors, like the ones at Wagner, they have them do things by hand, old school, and then some of the dual credit instructors have them do it using the TI-84, like we do. We use the TI-84, so it just depends on the instructor. But so the Connect Math videos show how to do this by hand. So you don't have to do it by hand. You have permission to use the calculator for these. And so you would just need to write the formula here, this, and then identify the N and the R, and then use your calculator to get an answer. Okay, this is a formula that will be needed for the permutation rule number 2. And then for the combination rule, this is the formula that we need. Okay. All right. So we're going to start with the fundamental counting rule. And it says that the number of ways a sequence of n events can occur. If the first event can occur in case of one ways, the second event can occur in case of two ways, and then et cetera, et cetera. So these are events, case of one times case of two times case of three, all the way to the last event. Okay, so that's the fundamental counting rule. And so, on your tests, you're allowed your practice test. When you take your test, it's a time test, and you're allowed your practice test. So you should write these down on your practice tests appropriately related to the related problem. And then you can make use of that when you actually take the test. And that's required. And when I review your work, you're required to show your work, upload your work, your template. Okay, so if we look at the first problem back on this page 118 where this section begins, 4.4 counting rules. It says the fundamental counting rule is also called the multiplication of choices rule. Okay. In a sequence of n events in which the first one has case of one possibilities, and the second event has case of two, and the third has case of three, and so forth. The total number of possibilities of the sequence will be case of one times case of two times case of three times all the way down to case of n. So one example we have is tossing a coin and rolling a die. So a coin is tossed and a die is rolled. Find the number of outcomes for the sequence of events. Okay. And so um, the formula that we would jot down, you would jot down like case of one times case of two, because we have two events. And then when you do your substitutions, what's representing the first event is that of a coin is being tossed. So, you know, that has either a tails or a heads. So that's got a possible, the number of outcomes that would be two things that can occur, two outcomes. So these are outcomes. Okay, and then times k sub 2. So this is your second event. Okay, and we're talking about a die being rolled. So a rolled die. And you know, when when you roll a die, look at the things that can happen, right? It can land on a side with a 1. It can land on a side with a 2. It can land with a side with a 3. It can land with a side with a 4. It can land with a side where you have 5 or 6. 6 dots. Because that's total 6. So 1, 2, 3. And of course, if you wanted to just write 1, 2, 3, 4, 5, 6, that would be fine, right? But that they've got 6, okay? And so 2 times 6 gives you a total of 12. So this would be your substitutions, and this is your answer. All right. So here's your formula. These are your substitutions, and then this is your answer. So this, if you're highly visual, you can put this out if it helps you. You can put T or H even if you want to take a shortcut. But this is not required, the drawing, but you're at least doing your substitutions 2 times 6. And that's where these are coming from. And that gives you 12. Okay. So this is the idea of the fundamental counting rule. Okay, here we have another problem. Types of paint. So a paint manufacturer wishes to manufacture several different paints, and the categories include the following. So they've got these colors. So this could be the first outcome, color. 1, 2, 3, 4, 5, 6, 7. This has 7 outcomes. Okay, this is your type. This one has 2 outcomes, latex or oil. This could be K3 event, the texture. 1, 2, 3 outcomes, flat, semi-gloss, high gloss. And then K sub 4, outdoor, indoor. So 2 outcomes. How many different kinds of paint can be made if you can select one color, one type, one texture, one use? Okay, so for you, you would have K sub 1 times K sub 2 times K sub 3 times K sub 4. And then when you do your substitutions, you would have 7 times 2 times 3 times 2. So 7 times 2 times 3 times 2. Yeah. So, you know, here's your formula. Here's your substitution. So I'll write this one more time. Here's your formula. These are your substitutions. And this is because this is tied to the first event. This is tied to the second event. This is tied to the third, and this is the fourth events. So I'm gonna just put events in the center. That's a lot of event. So first, second, third, fourth events. And then when I use my calculator and I multiply that out, 7 times 2 times 3 times 2 is 84. Okay. And that's also an example of the fundamental counting principle. All right. Okay, next page. So railroad memorial license plates. So the first year the state of Pennsylvania issued railroad memorial license plates, the plates had a picture of a steam engine and it was followed by 4 digits. Assuming that repetitions are allowed, so that's important. They're going to allow you to repeat how many railroad memorial plates could be issued. Okay. So as far as K1 through what do we need? We need because there's 4 digits, that means we need a K1 through K4. K1 times K2 times K3 times K4. And then with the first event, they're talking about digits. Well, what comprises digits? Well, digits would include 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 digits. So the first time you start with choosing a digit, any of these can take place after this picture of the steam engine, right? Then any of these digits can take place. But then when you get ready to come up with the second event for this license plates, right? They're memorial plates, memorial. These are memorial license plates, right? So repetitions are allowed. So like let's just say that we ended up with a 4. Then repetition is allowed. So second event, they'll let you have another 4. You could possibly pick a number for any of these. So second event, it's going to be 0 through 9. So digit 0 through 9 may occur. So any of these could pop up again, and including the 4 because they're going to allow repetition. So that would mean you have another 10. And this is going to keep happening for the third event and for the fourth event. That's going to keep happening. You're going to be allowed to pull up a digit. So this is going to be 10 again, and this is going to be 10 again. So this is actually 10 times 10 times 10 times 10. And this is equal to 10 to the fourth, which is basically, right, a 1 with 4 zeros behind it, right? So you have this key, see this key here? This key, this hat key, that's the exponent key. So this is 10, and then you raise it, see this? You raise it to the 4th power. Okay, and then that gives us 10,000. Okay, so this is 10,000. Okay, so that's the same as doing 10 times 10 times 10 times 10. See? And just remember the comma rule for this test, this probability test, the comma rule is going to be important. We will honor the comma rule. That will count as a rubric point. So the comma rule says that numbers with at least 5 digits require a comma. That's okay. That's the good rule of thumb. But commas are optional for numbers with 4 digits. Commas are optional for numbers with 4 digits. So you could, if it has 4 digits, you can put a comma or leave it off. So if I do an example on this side, like 3917, that's 4 digits. 1, 2, 3, 4. You can put the comma or you can leave it off. So you can do this or you can do this 3,917. So it's optional. Commas are optional. But if it has at least 5 digits, if it has at least 5 digits, so that means 5 or more, so then it's required. Let's see. That has 5 or more. 1, 2, 3, 4, 5. Yeah, so here it's required. Where here it's optional. Yeah, and so those of you who like Jeopardy, if you're a Jeopardy fan, this was actually a Jeopardy question in one of those games. And so it came out, this definition related to that. It's a Jeopardy question. Okay. All right. Okay, now let's go to um yeah, so if you're still writing, pause the video. If you're still writing, pause the video, and then you can start it again. Okay, but I'm going to move this up to example, the next example. Now, this example almost looks identical. Read that, except it's saying that repetitions are not going to be allowed this time. Okay. So what that means is that, like, let's say that you pulled out the 4 here on the first event, but repetitions are not allowed. That means from these digits, you have to remove it. You have to remove that 4. You have to remove that digit because they're not going to let you do 4, 4. They won't let you repeat it. So this is going to change. Okay. So we'll start off the same. Case of 1 times case of 2 times case of 3 times case of 4. And then we have 10. So this is the first event. So this includes digits 0 through 9. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. But um, let's say that 4 is is used. Let's say that 4 is chosen. So now when you choose your second event, this is times, when you choose your second event, it's going to be 10 minus 1, which is 9 digits available. So now you have 10 times 9. So you have to omit the digit chosen. You have to omit the digit chosen from, have to omit the digit chosen from the first event. Okay. So now when you choose the third event, now from the 10 digits, now you have to take away 2 of them. 10 minus 2 is 8. So you have 8 digits available. So now you have to omit the digits chosen from the first and the second event. So that's why it's 10 take away 2, which is 8, right? And then there's one more, because remember there was supposed to be four of them pulled out for this license plates that's going to show up with these 4 numbers after this steam engine. So you do have one more, and it should be 10, 9, 8. This one then should be 7, right? 10, 9, 8, 7. So this is the fourth event, and it's 10 minus 3, because you have to remove this one, this digit, whatever digit was pushed out or chosen. You have to remove this digit, whatever that would be. You have to move this digit, whatever that would be. But you have to take out 3 of them. And 10 minus 3 is 7. So what you have is 10 times 9 times 8 times 7. So how much is that? 10 times 9 times 8 times 7. It looks like it's 5,040. 5,040. The comma is optional. You can put it or leave it off. It's comma is optional here. Okay. So I don't know where I'm going to squeeze that. I guess here equals 5,040. So commas optional. Whereas on the first one, comma is required. Okay. Okay. So you want to, on this test, you want to jot that down on your paper, because that will count as part of the rubric. I believe it counts as part of the answer key on that. Okay. All right. So now let's see. Now we're talking about factorials. Let's see what's going on here with factorials. So factorial says is the product of all the positive numbers from 1 to a number. So I have n factorial is n times n minus 1 times n minus 2. So they have here dot, dot, dot. So they have 3, and then there would be, I guess, what, 3 minus 1 is 2, and then 3 minus 2 is 1. Okay. So they're letting n be 3. 3 times 2 times 1. Okay. So like 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. That would be 6 factorial, okay? And I'm going to show you doing, you can do this on the calculator, a shortcut, but you do it longhand. 6 times 5 times 4 times 3 times 2 times 1. That's 720. 720, okay? Okay. 0 factorial is, they're saying that's 1. So, and then we're going to find out what 1 factorial is. These are, we're going to use the, so we're going to use a calculator for these. So on the TI-84, you want to type the number, type the n, okay, whether it be 6 or 0 or 1, you type the n, okay, which is the number. And then you're going to press math. Okay, so like for example, I'm going to type 6, and I'm going to press right here, see, math. And then you have to tab to probability, PRB. Okay, so I'm going to tab to probability. And then I'm going to do number 4. I'm going to do number 4. See number 4? So I'm going to, I want 4 factorial. So I either tab down this way. Okay, so I can do this like, so you either tab down to 4, or you can just press 4. Either or, okay? And you see, and then you hit enter. Okay, and you get 720. Okay. So sometimes you might have to hit enter, enter. It just depends. So if I go back to 6 math, then I tab. Oh, I didn't go this way, sorry. So 6 math this way, and then go down to 4, then hit enter. Then I have to hit enter again. Okay, so sometimes you might have to hit enter twice. Or if I go 6 math, and I just tab down to 4, and then enter. Oops, what happened? So 6 math, probability, and then go down to 4, and then hit enter, then hit enter again, okay? Or 6 math, and then I just hit the number 4, hit 4. 6 math, go down to probability, and then just hit number 4, hit 4. There you go, and then hit enter. Okay. I think sometimes you have to hit enter twice, and sometimes it just depends which way you go, whether you press 4 or whether you go down. Okay, so now let's see what the value of, okay, so they're saying the 0 factorial is 1. We can test that. Let's see. So 0, hit 0, then math, and go to probability, and then number 4, and then hit enter. Yep. And let's do 1 factorial. 1 math, tab to probability, go to number 4, hit enter. Yep. Okay. All right. Okay, example 4-42, business location. Suppose a business owner has a choice of 5 locations in which to establish her business. She decides to rank each location according to certain criteria, such as the price of the store, okay, the parking facilities. How many different ways can she rank the 5 locations? Okay, so she's got 5 locations. So we're going to be doing a K1 through K5. Okay, and when we do the first event, okay, so we begin with 5 available rankings. Okay. So she wants to right, she's going to rank each location and she's got these criteria. So she's going to begin with some ranking, right? These locations, she's going to rank one of them. Maybe it's because the price is just right. It's got a really good price and she's going to keep her eye on it. But the first blank starts with 5. But then you know, once she uses that location, she can't rank it again. She's already ranked it as one of her top, right? So then she looks at the remaining. So now you have 4 remaining locations because it's 5 minus 1, which is 4. And then the third event is going to be after she ranks those 2. Now she's got the 5 minus 2. Now she's got 3 locations to choose from. And you got to keep doing this because she's got 5. So she's 2 more times. So she's going to have a 4th event. This is 5 minus 3, which is 2. And she's going to have a 5th event. So this would be 5 minus 4, which is 1. So you see, this is a factorial. This is the reason why this problem kind of follows this by factorial. It's 5. This is 5 times 4 times 3 times 2 times 1. And once you take it down to all the way down to 1, it's the factorial. So this is press 5, hit the math button, tab to the right all the way to probability. Then you can hit number 4, and then you can hit enter. It's 120. Okay, so I have 2 problems that are still dealing with the fundamental counting rule, and so I'm going to do that before I go to the next page. The next page I think is 120, and I believe it uses a new formula, I believe. But let me just do these. These are 2 from the ebook. These are from your ebook. You look at your ebook. Okay, let me write these down. So these are from your ebook. And this is teaching again examples of the fundamental counting rule. Here's EX means example, and it says visiting nurses. How many different ways can a visiting nurse visit 9 patients? If the nurse, it might be a female nurse or a male nurse, if the nurse wants to visit them all in one day. Okay, so here you're going to do K1 all the way through 9. Now that's a lot, right? K1 through K9. So you can write it out, or I'll let you do a little shortcut if you do it properly. K1 times K2 times dot 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 times K9. Okay. All right. So then when you do your first event, and these are all going to be the events. So there's 9 of them. The first event, let's imagine you have 9 patients, right? Imagine, let me name 9 people. Let's say you have John, Mary, Betty, Jane, Robert, and so 1, 2, 3, 4, 5, 6. Eric, Joshua, 1, 2, 3, 4, 5, 6, 7, 8. Josiah. Okay, so you say you have 1, 2, 3, 4, 5, 6, 7. Let's say these are your 9 patients. Okay, so once the nurse visits John on this first round, so they have 9 to choose from. So you have 9 available patients. But once the nurse sees John, then when you have the second event, this is going to be 9 minus 1 because that was, you already saw John. So 9 minus 1 is now 8. And then let's say on the second event, let's say you saw Jane. So you saw Jane on the second event. So now you get ready for the third event. Now you have 9 minus 2 because you're not going to go back and visit John again, and you're not going to go back and visit Jane. You're trying to visit everybody first. So no fair like going back to the same person. You already saw them, so you need to see these other people first. So minus John minus Jane. So 9 minus 2 is 7. Okay. And then this is going to continue. You're going to keep decreasing 1. So now let's say that you saw Joshua, or no, let's say you saw Josiah. Let's say you saw Josiah at the, let's say you saw Josiah at the third event, right? Or the third outcome, right? So now you have here on the next one, when you do the fourth, you have 9 minus, um, not including John again, not including Jane, and not including Josiah. So now you have 9 minus 3, which is 6. But you start getting a feel for the pattern. It's decreasing. 9 times 8 times 7 times 6. So then we're going to have times 5, and then times 4, then times 3, and then times 2, and I believe even times 1, because you're allowed 9. She's going to do 9 visits. So this is first, second, third, fourth visit. So these are and I guess I should put over here, I had third event. I guess you can call them events or outcomes. That's okay, events or outcomes. So um, on the fourth, 9 minus 3. So this is going to be um, fifth, sixth, seventh, eighth, and then ninth. So this is 9 minus 3, 9 minus 4, 9 minus 5, 9 minus 6, 9 minus 7, 9 minus 8 is 1. Okay. Yeah, so these are just decreasing. And so, and this is a true factorial. This is a 9 factorial. When it takes it all the way down to 1, when it takes it all the way down to 1, that's a true factorial. So, yeah, when it takes it all the way down to 1, it's a true factorial. So let's see what that is. So turn the thing on, calculator, 9 math, let's go to probability, and you can go to number 4, and then hit enter. And that's a large number here. Then remember your commas. 1, 2, 3, comma. 362,880. Okay. So on your work, the minimal work is you have your formula, and then you have these here. And you don't even have to put the little blank. If you don't want to put the little underscore blank, that's fine. But you do need to do 9 times 8 times 7. You do need to do these. All this other writing and things like that, you don't have to. The 9 minus 1, you don't have to, but you need to show the substitutions here. And then you don't have to do 9 factorial, because you could multiply it long ways. If you forget how to do the factorial, 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. You could always do that, and you should get the same thing. And then you need your comma rule. Okay. Okay. Here's one more example of this fundamental counting rule. So this says, how many 4-letter code words can be made using the letters in the word pencil if repetitions are not permitted. Okay, not permitted. So you might be thinking, well, how many? I need to go K1 through what? K1 through what? So we have this four-letter code. So I need to do four. K1 times K2 times K3 times K4. Okay. And then for the first, the first event, and the way they described it, yeah, I was just making sure event or outcome, but that's fine. It does say here K1 possibilities, and then the second event as K2 and the third event and so forth. So they do use events and then possibilities, so outcomes. So yeah, so the first event works with the word pencil, Pencil, pencil. 1, 2, 3, 4, 5. So pencil. 1, 2, 3, 4, 5. Pencil. So 1, 2, 3, 4. Oh, six. Is it six? 1, 2, 3, 4, 5, 6. Yeah, it's six. So the word pencil has six letters. There's six letters in the word pencil. Okay. And then you have the second event. Okay, so we have Pencil, and repetition is not permitted. So let's just suppose that let's suppose P is selected in the first event, but you're not allowed to use it again. It's not going to be repeat. So now what do you have left over? Oh, so then here I shouldn't have, pardon me, I shouldn't have P there. I should start with ENCIL. So I have 1, 2, 3, 4, 5. I have 5. Okay, so I have 6 minus 1, which is 5. These can work. And then let's just suppose E got selected. Suppose E is selected in the second event, and it can't be repeated, so you can't use it anymore. So now we have the third event. So now I'm left with um, NCIL. So let's suppose N gets chosen. Suppose N is chosen in the third event. So so um so let's see, I had a total of 6, and I have to take these two out. Take the P and take the E out. 6 minus 2 is 4. So I have 4 letters I can choose. 1, 2, 3, 4. 4 letters I can choose. And let's say that N gets chosen. Okay. And now I just have to do this one more time because I only have 4-letter code. See, 4-letter code. And these are going to be representing P's. Like here you would have a P and an E, and then let's say I have the fourth event. So now I have what's left, because these can't be used. What's left is CIL. So this is 6 minus 3, because these can't be used. 6 minus 3 is 3. So I have 6 times 5 times 4 times 3. Any of these 3 can get chosen, and let's just pretend that C got chosen here, okay, for example. But now I have 6 times 5 times 4 times 3, And then what does that equal? So let me put this here since it fits there. So this is not a factorial. This is not a factorial because it doesn't go all the way down to 1. It doesn't, because they said just 4, so it stops here. So this is 6 times 5 times 4 times 3, which is looks like 360. And if I were to edit this problem just ever so slightly, and what if I were to say now that the same problem, an aside, what if what if repetitions were allowed? Then how would this change? So you would have K1 times K2 times K3 times K4. And the first one, you'd have 6 choices. And then the second one, you'd also have 6 choices because they can all repeat. So you have P, E, N, C, I, L. And if you use P, you can use it again. P, E, N, C, I, L. So this is 6. And then again, and then again. So if it can repeat, these are going to be uh, 6's here. So then this equals 6 to the 4th, and you can use this key, right? The hat key. So you can either do 6 times 6 times 6 times 6, which is 1,296. Or you can do see this little hat right here? See my finger? Index finger, little hat. So you can do 6 and then that little hat, and then 4's power equals 1,296. Okay, next, what's coming up on the next page 120 is now we're going to talk about the permutation rule number 1, and we'll be making use of this. And your workbook, I think, shows you how to do it by hand. So we'll look at that, but you're not required to do it by hand. We're going to use the calculator. I'll show you that. The number of permutations of n objects taken r objects at a time. Order is important. Okay. So we have permutation rule number 1, and we have combination rule. And and in combination rule, order is not important, whereas for permutation it is. So the way I remember these is contrary to what you would think. Like, wouldn't you think you think like, I think they named it wrong. They made a mistake when they were naming it, right? Because when you think about a combination lock, think about your combination lock like you probably use in high school for your lockers or any locker that you might have. If it's not by a key, you have a combination lock. In a combination lock, the order is important. When you move your dial, you move your digits, and you open that combination lock by that code. But it's contrary to what you would think on a combination lock. You can see here, order is not important. So that's how I remember it. It's combination is they named it contrary to what you would believe, what you would think on that. Okay, so order is not important on the combination. So I think they kind of named it. They should have named it the other way around, but that helps me remember it. So we're going to do examples of the permutation rule where order is important. So let's go to page 123. No, 120. Go to page 120. Okay, so this is page 120 in your workbook. So it says that the arrangement of n objects in a specific order using r objects at a time is called the permutation of n objects taking r objects at a time. It is written as NPR, and then they have the formula. So again, on the test, this, you don't have to put this. I just need you to do this, and then your substitutions is what I need. So this, I'll consider this the formula, or the, the abbreviation for that. And then remember that what we said here, that on these we said that order is important. So I'm going to write that down here. So when you do your practice tests, these are things you want to write down on your practice test related to the problems that are related to that. Okay. Okay, so here's an example where they're doing it by hand. The notation NPR is used for permutations, 6, permutation 4. So like you have, this means you have 6 available. And this is like how many you're selecting. 6 available, and you're choosing 4, selecting 4, choosing 4. And they have 6 factorial, because this is their n. See how n is 6 here, and r is 4. So they have 6 factorial, 6 minus 4 parenthesis factorial. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 6 minus 4 is 2. This is 2 factorial, 2 times 1. And what they're saying is that these will divide out, like 2 goes into 2, 2 divides into 2 one time, and 1 divides into 1 one time. So those just, fall out, become ones, or trivial ones. So really you just have 6 times 5 times 4 times 3, which, whoops, 6 times 5 times 4 times 3, which looks like 360. Okay. Now, when we use the calculator, okay, when we use a TI-84, um, so okay, let me write the formula. NPR 6P4. Yeah, so like if you were working your problem on it for a test, you put this abbreviation, you put your substitutions, and then you have your answer. Okay, so these are your substitutions. And this is, you can say this is your formula or your abbreviation, or your formula or your abbreviation, or your symbol. You can say your symbol if you want. Okay, so on the TA4, excuse me, you want to type in value. Okay, so for us, the end value would be 6. So I'm going to do that. Okay, then you want to press math. Then you want to tab to probability P R B. And you see, we're going to be working shortly with also NCR. So we just got number 4 factorial, but look at there's NPR and NCR. So we're working with NPR right now. This is number 2. So you want to tab to probability, and then you want to press, you can press 2 for this 2 colon NPR. So you can press 2 for that. I'm going to hit 2, see 2 down here. So I'm going to hit 2 down here. Hit 2. See that? And then you're going to type the other value, which is the R value, right? You can type the R value. And the R value was 4. And then you're going to press enter. And you see how we get the 360? See how we get the 360? Okay. All right. Okay, so now we're going to show you how these can be worked with applications. And remember to keep in mind that these are examples where order is important. So we're going to, these next 3 problems, that we do are showing you examples where order is important. Okay. Okay, so first we say that um, business location. So suppose the business owner from example 4-42 wishes to rank only the top 3 of those 5 locations. How many different ways can she rank them? Okay, so she's ranking them. They've got a value, right? A designated value. So she's ranking this one first, and then this one second. This one's, so order is important. So on the test, to help you narrow of all your formulas. So in your test, you'll have like for sure one of each, one of this one of this kind, one of this kind, one of this kind. So to help you guide you to narrow it down to these 2, I will often ask you this question: is order important? Okay, so in this example, it is. Okay, it is, because we're working with the top 3 locations. So we're working with the top 3 locations. Okay. Okay, so my N and my R. So let me explain how I know what these are going to be. We're going to use NPR, okay, and because order is important, and N represents the amount available. It is oftentimes it is the larger number. So the larger number between the 3 and the 5 is the 5. So there's 5 locations available, but we're only ranking the top 3. So the R stands for the selected amount. And it's going to be the smaller number, because oftentimes you won't be able to pick all of them. So you have to choose. So you're going to pick, it's going to be smaller than what's available. And so the 3s are, that's a smaller number. So N is 5, R is 3. So then when I type that into the calculator, I have 5, I type press 5, and then hit math, and then tab to probability, and you want number 2. So you can also tab down to 2 and hit enter. And then you want to press 3, and then enter. And that looks like that gives you 60. Okay, so it works. Now, if you type it backwards, you can kind of get heads up that you made a mistake like us because you'll get something that's not logical. You know you need to have at least one outcome, right? One result. I believe if you accidentally switch them, I believe you'll get 0. So if I type it wrong, if I type 3, then math, probability, and I go to number 2 and I type 5, notice how that gives you a 0. So that helps you. That you got to have at least one result, right? So that can't be right. Okay. So it kind of gives you heads up on that. Okay. So the next one is also an example of order is important. Radio show guests. A radio talk show host can select 3 of 6 special guests for her program. The order of appearance of the guests is important. So this is really nice. They don't always come out and say that, but it's very helpful when they give you these clues that when I ask you, is order important? Excuse me, you want to say yes. Okay. And when we do in, which is the larger number, that would be 6 here. 6 guests available. And then R is equal to 3, smaller number. So these are the 3 guests selected. Selected amount. So we're going to use NPR. N is 6, PR is 3. Okay, so this is the selected amount. That's the smaller number. And then when I type this in the calculator, 6 math tab to probability went number 2. So you can go here, scroll down number 2, hit enter, and then 3, and then hit enter. Get 120. Okay, class, there's one more that the workbook gave you. We're showing you orders important and showing that we're using a permutation of objects. That'll be on page 121. So school musical plays. So a school musical director can select 2 musical plays to present next year. One will be presented in the fall and one will be presented in the spring. If she has 9, that's a lot, 9 to choose from. How many different possibilities are there? Okay. So so I'm going to ask, is order important? And we want to say yes. Okay. And so, because she cannot show the same, you know, play twice, right? She's got one for the fall, one for the spring. They need to be different, and the order which she picks them is important, right? Because they can't repeat. They shouldn't repeat on these musical plays. Um, and she's got a lot to choose from. She's got 9. So um, I'm going to say use id PR. Id is equal to 9, which is the larger number. R is equal to 2, which is a smaller number. And so when I substitute, here's my symbol. This is my symbol. Then I'm going to do my substitutions. So N is 9, P, and then R is 2. Okay. And so then we have 9, math, probability, number 2, and then 2. Enter. 72. 72. Okay. 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 So now I'm going to show you this permutation rule number 2. So I'm gonna just get a drink of water. So if you want to pause the video, let me get a drink of water real quick, and then we'll continue. We have a couple more pages to go, right? 121 and 122, 120. So we have 3 of these pages. Yeah, let me get a drink of water, and then I'm going to come back. Okay. Alrighty, class. So this is permutation rule number 2. Let me see. And that should be the same formula that's on here as well on the back sheet. This one just looks larger. The number of permutations of n objects where R1 objects are identical, R2 objects are identical, all the way to RP objects are identical. So in these formulas, you're gonna be given a word, and the n is the amount of letters in the word. And then when they say R1 objects are identical, you're gonna count like how many, like based on your different letters, like how many A's do you have, how many, how many B's do you have, or How many G's do you have? That's what this is based on down here. The amount of letters, the amount of letters for respective letters. Okay. So 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 it looks like this is the same formula here. It also says where R1 plus R2 plus all the way to RP is equal to N. Yeah, so that's the amount of letters. So let me write something down. Let me see. I had something written down over here. Yeah, let me write this out. This is going to be helpful here. So I'm going to say that we're going to let n equal amount of letters in the word. N is going to equal the amount of letters in the word. Okay. So it says letter permutations. How many permutations? So yeah, usually people say, how will I know when to use this formula? Usually they'll word it like that. They'll have letter permutations, or they'll say how many permutations, and then they're going to give you a word. Now earlier we did work with the word pencil, but that was something different. They didn't also say how many permutations, so that's a little bit different. Here it says of how many permutations of the letters can be made from the word statistics. And so in our formula, so we have n factorial over. So for us, n factorial, um, n is going to equal, if I count my words, 1, 2, 3. I mean, if I count my letters, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for us in this problem, n is equal to 10. There's 10 letters in the word statistics. So that way, that means that our numerator is 10 factorial. Okay, now students usually get that part right, but the tricky part is the bottom. Usually students miss it, and it's because they miss it because of the bottom. And I think it's because also the formula, you're supposed to put parentheses, and I think maybe that's why they forget to put parentheses, because you see it's not in the formula here. They really need to put parentheses around that, because otherwise, if you type it without the parentheses, you will get it wrong. And I can show you that without it, and show you get it wrong. Okay, now, now we're going to let R1 equal the count of the letter. So the count of the letter such and such. Like, so for example, for us, R1, we're going to let that be um, the count of letter. And I'm going to just start with S. With S. So if I count my letters for S, I'm going to highlight that in yellow. Let's see how many we have. So we have 1, 2, 3. Okay. So the count of the letter S is 3. So therefore, right here in my formula, R sub 1 factorial, for us, R sub 1 factorial is 3 factorial. Okay. And then we're going to let R sub 2 equal the count of the letter so and so. It's like the next letter. So here for our problem, R2 is going to equal the count of letter, and I'm going to just go with the second letter, T, T. Okay, and I'm going to use a different highlighter. I'm going to use orange for T. So I have 1, 2, looks like 3 also. So it looks like a count of 3. So this is r times 2 factorial, and for us it's also 3 factorial. Okay, and then here I'm going to just say like dot dot dot, like you keep on going till you exhaust your letter. So for us, I'm going to do an R3. Let R3 equal the count of letter, and I'm going to go to, you can go out of order if you want. So I think I'm going to go to I. You can go out of order if you want. So I, when look at I have an I here and an I here. It looks like I have two I's. So be 2. So us, we'd have R3 factorial, and then R3 is 2 factorial. Okay. And then we're going to let R4 equal the count of, and if you want, now that you get the gist of it, you can, now you get the gist of it, now you can just say, let this be, oh no, man, liquid paper, oh no. I have some somewhere else, but not here, I don't think. So I think I need to go get that. Okay, hang on. Let me get my liquid paper. Golly. Okay, I'm back. Let's see. So now you get the gist of it. This is R is equal to the count of, and we know these are letters, so this is the count of, so I'll leave out letter, and now I can say A. And A only shows up one time. Okay. Now remember, I want you to recall something. I want you to recall that 1 factorial was equal to 1. Do you remember when we talked about that earlier in our page? Remember on page 119? Remember 1 factorial was 1. Okay. So feel free to leave out the 1 factorials in your calculation. Feel free to leave out the 1 factorials. in your calculation, because it won't affect it. Anything times one is that itself, right? So times one, so it won't affect our value. So if you leave it out, it won't affect your value. And it turns out that R5 is going to be the count of C, which is also 1. So it's also 1 factorial. So if you want, you can actually, if you wanted to, you could, because these are 1, you could leave it off, and that I would be okay with that. So this, I'd be okay with this, and then you want to close it, okay? And then you're going to use the TI 84 now. Or if you want to include that, you could say that this is n factorial over r1 factorial times r2 factorial times r3 factorial times r4 factorial times r5 factorial. But then that's it. Don't have an R6 or an R7, because you don't have an R6 or R7 according to this. Okay. And then same thing here. If you wanted to do this, I have or you want it, you could do 10 factorial over 3 factorial times 3 factorial times 2 factorial times 1 factorial times 1 factorial. You could do that if you wanted to, but like I said, um, 1 factorial is just 1. That's why it's okay to leave it out. Okay, and when I use my calculator, I'm going to just do it for this one. So I'm going to say 10 factorial. So you do math, 10 math, and then you're going to tab, and you want number 4 divided by, so you want to press the division button. Okay, and you do need to put the parentheses. If you don't put the parentheses, it won't calculate correctly. 3 factorial, so 3 math, tab to probability, and then number 4. And then you don't even have to hit times. It's implicit, it's implied. So just hit 3 math, tab to probability, and then number 4 again. See? And then 2 math, probability, and then number 4 again. And don't forget to close the parentheses. If you don't close it, it'll make a mistake. And then hit enter. And that's 50,400. Okay, and then that would be your answer for that. So usually students on a test, usually students miss this, and I think it's because they don't put the parentheses. See, if I do a second enter to copy this, and if I go back and delete the parentheses and hit enter, you see you won't get the same thing. See that? You do need the parentheses. You do need the parentheses, because otherwise you won't get the same result. Okay. Okay, now if I have you practice that on your own, for the word Massachusetts, you think you want to practice that? Could you be able to practice that again? Let's see. So how many permutations can be made using all the letters in the word Massachusetts? Okay. So what would be good is if you were to, like at this point, stop the video and then do this on your own. So stop the video, like right now, stop it, and then do this on your own, and then turn it back on and then see if we get the same thing. That would be great if you could do that, okay? Okay, so then let's say I'm assuming that you did that and then we're ready to check. And excuse me, see if your answer was your answer this in the millions. Did you get 64,864,800? So did you get this? Did you get, if you got that, you did it correctly, I believe. Okay. So let's see. So I would start with the formula on the test. So you put your formula down. Oh, and actually, I'm actually noticing I left off something in this formula here. I'm actually noticing that I forgot the factorials. So I need to go back and add that in on this one. It should be R1 factorial times R2 factorial times R3 factorial. From the previous one we were doing. So this should be R sub 1 factorial times R sub 2 factorial times R sub 3 factorial. You see that, because see that there is the formula. This one would be R sub 1 factorial, R sub 2 fact. So you don't have these dots. You actually don't need these dots here. They're implied, but you do need the factorial. So this one would have gone all the way to R5. And actually, I think I did do that on our paper. Yeah, I'm sorry. I think I was looking at one of the ones I did in my remote learning classes. On that one, I didn't do it, but on the one we just did with you, this one, we did put them in. Yay. But I need to let that other class know, that remote learning class, let them know that we need that in the formula. Nobody said anything in class, so I need to let them know they didn't catch that. Or if they did, they didn't say anything. Okay. So we have R1 factorial. Okay, so we're going to say that n is equal to, and I want to write up the same way I did this one. N is equal to how many letters? Was it 13 letters? N is equal to 13 letters. So therefore 13 factorial. And then R1 is going to equal the count of, and I'll start with M's. So if I start my M's, And if you did get the answer, you can just fast forward, right? If you did get the letter, you can fast forward. So um, R1 is equal to count of M, which is 1 factorial. There's just one M. And we actually said that we could leave off one, right? Like if you end up having 1 factorial, we said we could leave it off, right? So actually, because R1 is going to represent M and it's 1, we could actually leave that off here then, right? So um, R2 is the variable A. How many A's do we have? Looks like 2. So that gives us 2 factorial. So the 1 factorial you don't really need, but we do need R sub 2. And then R sub 3 is going to be the variable S. So I got the A's. Now I got S's. So here's 1, 2, 3. Wow, it looks like 4 S's. So it's R sub 3 factorial, which is the S's, 4 of them. R sub 4 is equal to, after S's, I'm going to do C's. How many C's do we have? Just 1. And we don't have to include the 1 factorial. So R sub 5 is equal to the variable H. How many H's do we have? 1 here. That's it. Okay. R sub 6 is equal to, and we already know variable. So if you don't want to put the variable, then you got the gist of it. Now we're looking at U. And what's the count for U? The U is just 1. R7 is the variable E, which is also 1. And then R8 is the variable T, and that's 2. Okay, so I'm going to say R8 factorial. So basically I have 1, 2, 3, because all the other ones were 1s, but I have 1, 2, 3 that were not. So I make sure I have 3 R's, and then I'll make sure the subscript matches with that assigned letter. Okay. And so this is 2 factorial. Okay. And then now when I type this in the calculator, and remember the reason why remember 1 factorial was 1. So we may omit 1 factorials from our calculations, because anything times 1 is itself. So we may omit the 1 factorials. Okay, so but when I type this in my calculator, I type in 13 math probability, and I want number 4, divided by open parenthesis. Then I have 2 math probability factorial. And then I don't even have to do times, it's implied. 4 math probability factorial, and then times 2 math probability 4, and then close parenthesis, and then enter. And then I have that value that I mentioned earlier. 64 comma 864 comma 800. And remember here, commas are required. That's in the millions. That's a big number. Okay. All right. Okay, and then the last topic is now we're getting into that combination rule, this one, where order's not important. Combination rule. Okay, so let's go to page back to 121. And then 122. So a selection of distinct objects without regard to order is called a combination. Okay, so the difference between a combination and permutation can be shown using the letters A, B, C, D. The permutations for the letters A, B, C, and D are these. So remember what we said about permutations. If I go back to my vocabulary, remember we said with permutations that order is important. Okay. Order is important. So that means like AB is different from BA. Even though they both have A's and B, the order's important. So AB is distinctive from BA. So so in other words, AB is not the same as BA, for example, here. And also AC is not the same as CA. So AC is not the same as CA, okay? And so on and so on, right? BC is not the same as CB. AD is not the same as DA. BD is not the same as DB. And lastly, CD is not the same as DC. Right. So their order is important and they're all distinctive. These are distinctive. Okay. So that's what that little demonstration is. Okay, and then let's see what's happening on the next page, on page 122. In permutations, AB is different from BA, but in combinations, AB is the same as BA. And that's because in their definition combinations, it said order is not important. And it says the reason AB is not the same as BA. So we're talking about AB is right here, is not the same as BA. Since the order of the objects does not matter in combinations, therefore if duplicates are removed from a list of permutations, what is left is the list of combinations. Okay, so you see here AB, they're removing BA, and you see here AC, they're removing CA, and you see AD, they're removing DA, and you see BC, they're removing CB, and then you see BD, they're removing DB, and then you see CD, they're removing DC. Hence, the combinations are of A, B, C, and D are these left. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6, 6 objects, I guess I can say. Yeah, I guess I could say 6 objects. Yeah, the number of combinations of R objects taken R in objects. Okay, so objects. Okay, so I've got these 6. Okay, so there's fewer then, right? Okay, so in combinations, again, your little video, they might show you how to do it by hand, but we're allowed to use a calculator, and you want to put down your symbol for that, and then you would do your again in and okay again. Okay, I'm gonna do 2 things here. I'm gonna again put order is not important because I don't think they have that here. And the N and R will still represent the same thing. So N represents what's available. So I go back to my other notes and word it the same way. It's what's available. And whereas the R is what's selected. So I'm going to go back to how I worded that. The amount available. So N is still the amount available. And this is still going to be the larger number. That doesn't change that. whereas R is going to be the selected amount, right? Let me see how I'm going to word it the same way. So the selected amount. The smaller number. Okay. So these are supposed to be examples showing now combinations. What's remaining? These three problems are going to be that. And then I did do one more from the ebook. One from the ebook. Okay, let's see. So it says that combination. So how many combinations of 4 objects are there? Taken 2 at a time. Okay, so this is the larger number. 4 objects. So that's going to be n is equal to 4. Taken 2 at a time. So that's r, smaller. R is equal to 2. So we're going to use NCR, and n is going to be 4 combination 2. So how many combinations of 4 objects are there taking them 2 at a time? Okay. So in the on the computer also, again, we're going to you would want to, on the TI-84, you would want to type in value. Okay, so I'm going to type 4, and then you're going to press math, and then you're going to tab to probability PRB, and then this time you want number 3 in CR. So I'm going to you either go down, scroll down to 3, and then you hit enter, or you press the number 3, and then you want to type R value, which for us it's 2, and then you press enter, and that gives you 6. Okay. Okay, last page. Flyer types. An advertising executive must select 3 different photographs for an advertising flyer. If she has 10 different photographs that can be used, how many ways can she select 3 of them? Okay, so the larger number is 10, that's n equals 10. The smaller number is 3. And remember, I always ask you, that helps you narrow it down to which of these 2, because you have all these formulas here, and these 2 I'll prompt you with, is order important? And here, because we're doing combinations, on the combination, order is not important on these. Okay, and these are examples of combinations. So you're selecting photos, and you have 10 different photos, and it doesn't matter the order in which she selects. It didn't say anything about it being important. She just needs to select 3 of them. Okay, 3 pictures. And so we're going to use NCR. So 10 combination 3, taking 3 at a time. Okay, so I'm going to press 10, math, tab to probability, and we want number 3, hit enter, and then type 3 again, and we get 120. Okay. Okay, now this example is going to use, it is going to use combinations, but it's going to use a product. And you might have some of these on your homework, but I didn't include those on the test or the final. These are a little bit harder because it involves either multiplication or addition, and it can, this one's going to use combinations, but sometimes it's combination or permutation. So I'm going to show you one of each. So this one says that um, committee selection, and I have two problems, so I might try and squeeze both of them on here. So like I might try to see if I can squeeze both of them on it to save paper. Let me do this. Let me just cut this in. How many inches is this? 2. So try and do an inch, then an inch for each. Let me see. So that I can put the other column at the bottom. So I don't have to use another paper. I'm going to try that. Hopefully that'll work out. We'll see. So committee selection. So in a club, there are 7 women and 5 men. And a committee of 3 women and 2 men is to be chosen. So how many different possibilities are there? Okay. So in this example, is order important? And we would say no. Okay, we want to select women and men, okay? But in our formula, their form is going to be this. We're going to use this. NCR times NCR. And the first one has to do with the women, and the second one has to do with the men, okay? So on the women, there were 7 women, and on the R, you're going to choose 3 of them. So that's 7 combination 3. And then for the men, there's 5 men, and you're going to choose 2 of them. Okay. Yeah. And then here the idea would be to multiply. On the next example, I'm going to do one where we're going to use permutations, and I'm going to be adding on that. But this, it would be, I guess, what more appropriate, or to multiply as opposed to add. Okay. And that's where it can get tricky. Like, how do you know multiply? How do you know when to add, right? And so on your test, we'll just stick with the basic ones on the test. On the homework, we put a couple of these on your homework, but this would be, we need to use the multiplication idea here on these to get the right amount. If you add, we wouldn't have the right amount on these here. Now, when I type this in, I'm going to do 7 and then math and then probability and then combination, and then 3. And then here, let's see, I think here I do need a times. I know earlier we didn't need a times, but now we need to put in a new problem. So yeah, here I believe we do need a times 5, then math, and then probability, and then number 3, and then 2, and then enter. Yeah, they're supposed to get 350. Yeah, let me do a second enter. Let me do second and enter. Let me just if I let me see, let me just delete that. Let me try it without the times. I think you do need the time. Let me just try without it. 7 math probability number 3, and then 3, and then let's say I don't put the times. So then I do 5. Yeah, I do need it because see, if I do 5, it thinks it's 35. If I do 5 and then math, probability, combination, and then 2, let's see if I get the same thing. Oh, nope, I get a 0. So there's something wrong with that. So you do need this times. So you need that. And let's just see if I were to do a plus. Let's just see, it should be a small amount. So if I do second enter, I want the first one to see. Second enter. See, second enter brought the first one back. Let me just see what happens here. If I change this to a plus sign, I'm just curious on the amount, what happens. I do get a much smaller amount. See, I only get 45, and that's a much smaller amount. So, I mean, I guess if you think it through and you were to sit down and try and, imagine, how last time I had little olive seeds, like little tokens for the seven seven women, and then the 3, you're selecting 3. If you go through that, you're supposed to get a lot, 350 to sit through that. Um, and so this would only give you 45. So you see, you'd be shy quite a bit on that. Okay, now the last one we're going to do is the problem says, let me write this down. Signal flags. How many different signals can be made by using at least 3 different flags if there are 5 different flags from which to select. Okay, so I'm going to ask, is order important? So I would say yes, here order is important, because if you think about like the Boy Scouts and the Girl Scouts, I probably mostly they would, when they go out and they learn about um, they go out and they learn about safety and nature, right? Flags. maybe SOS type of flags to set up. Okay. Or even if people are in the Navy, right? They go on the ocean, they have to have these flags that they put up, right? For displaying flags for safety on their vessel, on their ship or what have you, their battleship or whatnot. Okay, but yeah, so the idea of flags order has to be important because they have to convey different things, right? So the order would be important in which you arrange the flags. Okay, so order is important, and here, um, here on this problem, we had women and men. What's happening here is like how many variables do we need? Part of the formula. Um, the keyword says at least 3 different flags. So this part here, at least 3 different flags, that that means this means um, this means 3 or more, right? At least 3 means 3 or more. Okay, so at least 3 means 3 or more. And so that's why when I start this here, and we're gonna use NPR, okay, because we said order was important. But when I first start the first one, I'm gonna say uh, how do I want to write this? I'm gonna say that N is 5 and R is 3. Okay, because the 5 is coming from this. You have 5 different flags. So you start off with n equaling 5. So this would be 5p3, okay? And then I'm going to do plus, and then I'm still going to have n equals 5 for all these that I have, right? But now R is going to be 4. So at least 3 or more. At least 3 or more means 3 or more. So 3, 4, 5. So then here I have 5p4. And then remember the total was, I mean, I can't go up to R being 8 or more than, because I only have 5. So I'm not going to, R is not going to be any higher than that. Remember R has to be the smaller number. N is the larger number. So then next I have N equals 5 and R equals 5. So this is going to be 5p5. And that's what I'll be figuring. That's what I'll be figuring. Okay, so these are these are the flags that are available. There's 5 flags available. And then these are the ones that we're selecting. These are the selected selected flags. So you're choosing 3, 4, 5. Okay. Okay. So then when I do this, we have 5 math, probability, and then NPR, and then 3, and then plus 5 math, probability, NPR, which is 4. And then now we're doing this one. 5. So plus, don't forget plus. 5, math, probability, NPR, 5. And then enter. Yes, and I had gotten 300, so I want to make sure I got 300. Got 300. Yeah, so let me just see if I just change this to times. You're probably wondering why not times. So if I go back and I hit times here, and I go back and I put times there. Let me see what that just comes out. I'm just curious. What does that come out to be? Ooh, that's a lot. 864,000. That's a lot. Yeah, that does it seem logical? That would be like an overabundance on that from just 5 flags. How many different signals that would be? Poor Boy Scouts, right? That'd be a lot of signals to keep track of. Yeah, even though 300 is a lot too, but it's not as much as that. Yeah, so the addition's more appropriate here for what we're doing with these flags. Um, and and I I want to say I'm not sure that's always true. That maybe it's that when you work permutations, maybe we always use addition, and maybe when we do these combinations that we always do multiplication. I'm just not sure. I haven't done enough. You have to do enough problems to look at that and you pick up on a pattern of that. Okay. But it's always good to see both, like what if I had used the times, and you see that just a bit too much with just 5 flags, right? Okay. So again, on the test, I won't put any of these on the test. These or on the final, but there's a few on your homework for practice on that. And then on the test, it'll be you'll have definitely one of each type of these basic types that we did. Okay, so I just wanted to show you these. Didn't want to omit those though, but those are on your homework. We just didn't put them on the test. Okay. All right. So good luck with that homework set. Then have fun. Hopefully you enjoy this 4.4. So it's a lot easier, I think, than it's different. It's a lot easier than the previous section, 4.3 is multiplication principle is one of the harder sections in our statistics course and a probability. Okay, good luck with that while you're studying. Take care.